Claude Opus 5 just dropped and it seems to be excellent at agentic coding. So I spent hundreds of millions of tokens to give a huge task of building an investment committee with 6 desks, including a chief investment officer and a risk function that can have as a pass or a fail check. And running the tactical asset allocation for a period of 5 years. And as you can see, Opus has been scoring high in a lot of different areas. So I decided to structure complex tasks. To research, I went looking at how people are actually doing this and the best practice of agentic finance. The main reference I found was the CFA Institute Agentic AI for Finance. It's a good paper and gives the vocabulary and the difference between workflow and a real agent. And this third case study is almost exactly what I wanted to build, a 6-agent pipeline for picking a portfolio. It's generally useful but already dated because it walks 6 agents and one at a time, and actually 2 of them could have done the tasks, which is the real lesson here because the architecture existed because models could not hold 5 scoring dimensions at once. And nowadays, the models have more than 1 million of context window tokens. One agent can basically do all these tasks. Then I read Anthropic themselves about it, and it's insightful because you delegate only for work that is generally independent and parallel. And you should not delegate where you could finish yourself in a few 2 calls and not use sub-agents to check your own work. And well, guys, if one agent can do it, just use one. And because their own mid-agent system beat a single agent by 90%, but consumes 15 times more tokens. Then I read again the Vols AI Finance benchmark, which one actually tries to measure this benchmark. I have a video about this, guys, by the way, and Opus 5 currently is the one that is one of the leading ones. And in the end, guys, in a field that advances so fast, academic research cannot catch up with it. And in the end, the best way to try it is to, well, just get into it and try yourself. So yeah, let's start. So I put some files here first, and this is the mandate, a university endowment, 850 million in assets, which it has to fund the university forever while paying out every year. And the board has set a drawdown limit that fits the return target. And here's the policy portfolio, 9 asset classes, and each one has a range that is allowed. And this is the prompt, around 5,000 words, because I am pushing Opus as hard as I can here. And I'm not reading it on camera. The prompt is here on the description. So instead, I'm going to explain what it's actually for. And that policy portfolio is the strategic asset allocation, and the tactical asset allocation is what moves against it. Every quarter, the committee decides whether to hold or tilt away from it. And the prompts put the model as the chair of chief investment officer and gives it six desks to staff: capital markets, quantitative, macro, implementation, and risk desk. The risk desk is the one I would point at. It does not advise, it rejects. Its compliance test is cold, and nothing reaches the committee until it passes. And the Quant and the macro desk are sealed. They reach their allocation without seeing each other's work, so it works like a firewall. I never tell them which methods to use. The Quant desk goes and finds its own research literature and decide which model is the best to implement. And so right now, guys, I'm gonna paste the prompt, and I'm also gonna open my extension I built so you can visualize all the agents at the same time. It's for free, and you just search agents max here in VS Code and you get it. So it has an orchestrator, and it just spawned another agent, which is called capital market desk. And yeah, right now what it's doing is researching capital market expectations for the fund endowment. So it's like a reading the mandate and making the decisions based on that. And here you can see all the historic of what it said, all the 2 calls, researches of every agent, including the orchestrator. So right now 2 agents building, and yes, you can see everyone has its own context window, the number of 2 calls and everything. So right now it's searching JP Morgan long-term capital market assumptions, and it's saying we'll start looking at web tools and which working directories. And right now another agent spawned. This is the systematic desk, and right now what it's doing, it's researching the Wealth and Goya, a comprehensive look at empirical performance of accurate prediction. And I didn't ask him to research this paper specifically, like it made our decision. So right now 3 agents working and doing different tasks. And here you can see all the agents, the dialog, the log, and the trace calls, which is the historical of all the 2 calls and the detail of what is actually doing. And yeah, like look at the web research, McLean Pontiff 2016. And right now the orchestrator says something to them. You are the implementing operation desk. So it's talking with these 2 agents. So the orchestrator is delegating these tasks to them, and another agent spawned here, addition and operation desks. And yeah, a lot of other agents spawned here. You see the amount of build tokens and all the chat. It's like a chat thing between all the agents. The log, And again, guys, the trace that is getting larger and larger. And now I'm accelerating the video to see all the, like, in a faster rate, because it took like a lot of time to run this. And you see all the agents working dynamically. And right now there are 6 agents, and you can have agents and sub-agents. And now you see the macro and the quant agents, which are, I think, one of the most important ones. And they have like this firewall system where they make their own decisions and different methods, and then it's decided which one is going to be applied. You can see which actions they are doing, researching ETFs, and now one thing interesting, like validating the Lloyd Wolf implementation from the Quant desk. So it's probably doing asset allocation because it has to do with covariance, shrink rate, and everything. And there's 2 desk disagreements here with 16.3 percentage point apart, and another one, composite R-squared of 1.61%. And that's the thing, guys, I didn't ask which paper they had to do. They do by themselves. And here, the dialog desk is getting larger and larger. And the log, where you can see all the historicals and all the bash and writes, the 2 calls of what everybody's doing. And well, you can see also the not assigned agents more below. So they spawned a lot of agents in the... Now it is finished, guys. And you can see the outputs, like you can see all the JSON historic files of every interaction is in the agents, the reports, all the Python files, all the tests made. And you can also check like the desk's MD, the MD files of define everything, like the implementation, like what they're doing, the 3 things, the macro desk, what are the orders. Yeah, it's a very complete output. And you can see also a very interesting one that I call the decision record. It's like, since it's like a 5-year files, and you have like quarterly decisions, you can see what was the consensus of every quarter. So for example, here in 2023, there was like a decision to US duration because they were predicting a high growth one. And also the annual report, which was based on the design system. By the way, I have a video about it. And yeah, it's a very large report. You can see it kind of was superior than the benchmark, and all the active return it had in each quarter. By the way, it's not revised, guys, like it was just made. And yeah, I would recommend to revise everything, because yeah, this was all AI made. I didn't recheck everything. It's a very large report, guys. Like there's a lot of different pages, and so it's nice to see which kind of allocation decision that made the, it's be superior than the benchmark. And now I'm gonna open another kind of dashboard, which is the historical of like tilts and everything. So you can see like each quarter what was the decision, tilt or unwind, based on the regime, like overheat, disinflation, based on what the committee decided. And yeah, guys, there are like a lot of files, and I've put here on the GitHub everything you need, so you can check it and do some audit checks. And by the way, it's very important, you guys, you also click here in the audits.md, another thing I built, which is like 2 other agents revising everything that was run. But again, there was no human supervisor doing it, human in the loop or anything. So it would be very nice to check, like, by the way, the audit, they didn't check like if they were look ahead bias, like if they were checking data like 2022, if they were checking data for 2023, for example. By the way, the audit didn't get it, but the best way to do it is like checking the Python scripts and check the data that they were actually using to see if they really passed the check. But I think there was this kind of bias. It's very hard not to have it, because all the economic data is revised after, and it's a very large problem, and I don't think it was solved. But anyway, that's it, guys. I hope you enjoyed the video, and we see in the next one.